Alright guys, today we are going to find the average rate of change given a function and an interval, or an equation and an interval. Okay, so it looks pretty scary, but it's really not that bad. So, a lot of the times when we're thinking about rate of change, we're thinking about how something's changing on a graph. Okay, so let's look at this. Alright, so our rate of change. So if my picture looks like this, okay, this is my line. Alright, now I want to figure out how we're changing from this dot to this dot. Notice if we go pencil. If we go up here, this point right here is where my x is equal to -2. And at this point right here, this is where my x equals 5. So this dot is where my x is equal to -2, and this dot is where my x is equal to 5. So that is a range that I'm talking about. I want to know what the rate is between these two dots, this spot right there. Okay? Alright, now when I have a picture, it's super easy to figure out. I would count my rise, 1, 2, 3, 4, 5, 6, and then I would count my run, 1, 2, 3, 4, 5, 6, 7. And my slope, or my rate of change, would be 6 over 7, a rise of 6 and a run of 7. And it doesn't reduce. It's a going up slope, so it's positive, so I have a positive 6/7. Okay? Now, when I'm not given a picture, I still want to figure out this rate that my graph is going. So I would need like a table of values and an equation to help me out. Well, my two numbers that I would put on my table of values are right here. My x would be -2 and my 5 would be my other x. These are my two x values because those are the two dots that I want to know how much we're changing in between those two dots. Then we figure out our y values using our equation. Okay? So this is the idea behind what we're going to be doing today. Notice that we gave you an interval right here. Okay? Now I have an equation and I have an interval, and this interval are going to help us make our table of values. I want to know what my rate is between -2 and 3. So those are my two x values, -2 and 3 on my picture. So if I were to graph, it would be, okay, well, what happens when my graph goes from 1, -2 to 1, 2, 3? So I would want to know what my graph looks like in between this area and how much it's changing from one side to the next. Well, without drawing a picture, we are going to plug in our values and figure it out. Okay? So the first thing you need to do is you need to take your x values. Since we know x is equal to -2, we're going to plug that into this x. So we're going to take out our x value and replace it with our first x number, which is -2. Since my x and my number are sitting right next to each other, it means multiply. And then we have to add 7 at the end. Well, 2 times -2 is -4, plus 7 is 3. So that's my first y value. So my first ordered pair is at -2, positive 1, 2, 3. Okay? Then my next value is 3. So I'm going to do the same thing. I'm going to take out my x value, and I'm going to replace it with my 3. Then we add 7. Well, 2 times 3 is 6, plus 7 is 13. Okay? Well, I don't really want to graph that on here because that would be really tall, so that goes here. Okay, so now because I don't want to put my whole graph on my paper, and some of these graphs get really big, we're just going to see how it's changing. To go from 3 to 13, we are going to add 10. To go from -2 to 3, we are going to add 5. Okay? So now what we're going to do is, in order to figure out our slope, our rate of change, we take our two values, how much our y is changing and how much our x is changing, and we make a slope. So our slope, or our rate of change, is our m, which is our y over our x. So our change in y is 10, and our change of x is 5. If you can reduce, you must reduce. 10 divided by 5 is 2. So that is our rate. And there are quite a few steps, but they're not too bad. It's kind of putting lots of ideas together. Okay, let's do another one. Alright, so we are going to make a table of values, x, y. The two x values are the two values over here. So this is an x value and an x value, and they go into our table. -4 and 2. Okay, we're going to start by plugging them in to where my x is one at a time. Remember, when your number and your letter sit next to each other, it's really saying 5 times x plus 6. So we multiply. Okay, so we have 5 times -4 plus 6. 5 times -4 is -20, plus 6 is -14. Okay, now we're going to do it again, but with 2. 5 times 2 plus 6. Well, 5 times 2 is 10, plus 6 is 16. Okay, so now we are going to add, and we're going to figure out how to go from -14 to 16. So -14 plus 30 is 16. And we'll check it just to make sure we're good. -14 plus 30 is 16. Yay! Okay, and then we're going to do the same thing here. So -4 plus 6 is 2. So we're adding 6 on this side. Okay, so then we're going to write our slope. It's our change of y over our change of x. Y is changing by 30, and x is changing by 6. 30 divided by 6 is 5, so our rate of change is 5. Okay, hold on. Okay, now the same thing happens if you have a fraction, so don't worry, it's the same idea. Okay, so we are going to start by making a table of values. We have an x value and a y value. Our two x's are -6 and our 4, so we have -6 and 4. And we're going to plug those in. So we have 1/2 times -6, so half of -6 is -3. And then we have 1/2 times 4, well, half of 4 is 2. Well, how do we go from -3 to 2? We add 5. How do we go from -6 to 4? We add 10. So our slope is our change of y over our change of x. Y is changing by 5. X is changing by +10. 5 over 10 reduces to 1/2. Okay. If you notice on the linears, so these are linear because I don't have an exponent, my slope is the number that matches the slope. Like, you don't even have to do these for the linear. My 2 matches my 2, my 5 matches my 5, and my 1/2 matches my 1/2. So if you've watched the video this far, now you know a cool trick. Okay, so now we need to do some exponential examples. Okay, and we're going to do that together in just a second.